board. All right. So here is our triangle. Try not to make it isosceles. So A, B, and C. Across from the A, we've got little a. Across from the B, we've got little b. Across from the C, we've got little c. And we'll draw a height perpendicular right there. The law of cosines is going to help us out in a side angle side situation. It's also going to help us out in a side situation. Okay, but that might not mean anything to you right now. I'll just say right this: with the law of sines, we saw that helped out with an angle side and an angle side. This is going to help out with the side angle side and the side. If you don't really care about that, don't worry about it. All right, what are we going to do here? We are going to focus in on, I need to do a little more labeling. I'm going to call this right-hand side here, this length here, from C to that H height line, that's going to be X. And so the remainder over here is going to be A minus X. Okay. It's not too long. That's it. That's all I'm going to do today. Just generate the formula. Let's focus in on this left-right triangle. So, like always, Pythagorean theorem here, class. So, hypotenuse c squared equals a minus x squared plus h squared. And while I'm at it, we'll go ahead and look at the right-hand triangle over here. Let's write Pythagorean theorem for that one. So b squared equals x squared plus h squared. All right, time to do some foiling here. I guess, so a minus x is really, sorry, a minus x squared is a minus x times a minus x. I shouldn't have to write this all out. Y'all are honors pre-cal students, but I will just so that we're all together. So a times a is a squared. A times negative x is minus ax. Another minus ax gives me minus 2ax. And a minus x times a minus x, or negative x, plus x squared. And then we've got that plus h squared. So a squared minus 2ax plus x squared plus h squared. And you might say, x squared plus h squared, we just wrote that over here. You are correct. So I'm going to substitute b squared for that. So now I have c squared equals a squared minus 2ax plus b squared. Little side problem here. I also really don't like that x here. Some people I can try to get rid of that. Looking over here on this right triangle on the right side, let's talk about cosine of angle C. I'm going to let y'all tell me about cosine of angle C. Cosine is adjacent over hypotenuse. Anybody want to make a guess what that ratio is going to be? X over B. We'll multiply both sides by b, so we have b cosine C equals x. And we say, there's an x right there, and there's an x right there. So I'll write this as c squared equals a squared. Now I wonder if y'all are comfortable with me doing two things at once. I'm going to put this plus, I'm just going to rearrange this so that it's kind of alphabetical. Alright? If you remember when you're adding and subtracting things, you can do all that and it's all the same thing. 2 plus 3 is the same thing as 3 plus 2. You know, you can commutative property, drive them all around there. So I'm going to write that as a squared plus b squared minus 2 times a, and then instead of saying x, I'm going to write b cosine c. C squared equals a squared plus b squared minus 2ab cosine c. All right. That's it. That's the law of cosines. One side squared is equal to the sum of the squares of the other two sides minus 2 times their product and the cosine of the included angle. Can we say that again? Any side squared is equal to the sum of the squares of the other two sides minus 2 times their product and the cosine of the included angle. One more time. Any sides, well, let's write it down in variations. I've got A, B, and C, right? Okay, but really, I could have labeled this is C, and this is A, and this is B, right? So it doesn't really matter. So let's get a little bit more familiar with this. What if instead of saying C squared, I had just written A squared, okay? Any side squared is equal to, now repeat after me, any side squared is equal to the sum of the squares of the other two sides. I'll write down here and then you can say it. The sum of the squares of the other two sides. So repeat after me. The sum of the squares of the other two sides.
The sum of the squares of the other two sides.
What would that be in this case? If I have a squared as my side that I'm choosing, what would be the sum of the squares of the other two sides?
B squared plus C squared.
Well, let's alphabetize this here, folks. B squared plus C squared. Okay? Minus, everybody say minus.
Minus.
The product of the other two sides and the cosine of the included angle. That means of the angle between them. So repeat after me. The product of the other two sides and the cosine of the included angle.
The product of the other two sides and the cosine of the included angle.
Beautiful, beautiful. Music. All together now. We'll say it as a group. Ready? 1, 2, 3. Any side squared equals the sum of the squares of the other two sides minus the product of the other two sides and the cosine of the included angle. Amen. Minus. Alright, 2. Now in this case right here, what would my, instead of A and B, it's going to be B and C cosine A, alright, because A is the side that's across, angle A is between B and C, in case you don't know that. Alright, it's not across from B, it's next to B. So then, or, this is an alternate version, but it really doesn't matter, B squared equals, yeah, so what's the first letter I'm going to write here? A squared plus C squared minus hooray! We have it up front. Mr. Greensburg, we have copies of this.
Yep.
And he's got it pulled up. Thank you. Where's that?
Copies here.
Love cosines. Some for you. Pass one down. second row. Pass them on down. You might start to be concerned that there might be a law of tangent, law of cotangent, law of cosecant. But you don't have to worry, there is not any of those laws. Just law of sines, law of cosines. I don't know, Mr. York may have told you law of sines, law of cosines. Did he?
No.
Alright, no computers just yet. I'll try to get you some time here in a minute. Alright, here we go. Everybody got one? Murray got one? Good, thank you. Consider the triangle ABC like the one shown below. Let's go ahead and start labeling it. Suppose that A is equal to 40. B is 34. C is 66. The figure is not drawn to scale. Solve the triangle. Carry your intermediate computations to 4 decimal places and round ratios. Solve the triangle. Preston, what does that mean, solve the triangle?
You can take or find the A, B, and C.
Find all the angles. Yeah, find all the missing pieces. There's always 3 sides, 3 angles. So there's 6 pieces. They give us 3 of them. Okay. They gave us a side, side, side triangle. You may remember from geometry that anytime you have 3 sides, there's only one unique triangle. Okay. And the way that in geometry sort of played out was if you had one triangle had these 3 sides, another triangle which had those same 3 sides, then you could jump to the conclusion that those 2 triangles were congruent and everything about them was the same, because there's only one unique triangle that has those 3 sides. There is only one unique triangle that has a 40, 34, 66 side. So no ambiguous case here, no situation where there's 1 triangle or 2 triangles or 0 triangles. Okay, it is possible that they could throw you some numbers that won't legitimately connect, like the 100 and the 1 and the 2, but they're not going to be jerks like that on this. Okay. So, we get to choose which of those 3 sides that we want. And I'm going to tell you, pick the smallest one first. Okay? It's a little bit, it's like, sort of like a hidden piece of information. Always pick the smallest first. Just in the unlikely event that you have an obtuse triangle and you get a weird answer and do inverse cosine. So, remembering that the small, what's that? What do you think? You pick the largest side first? Why the largest side? Maybe you might be right, I can't remember. I thought it was the small side. Do you remember why?
Yeah, because of the obtuse are, if one of them is obtuse, R is acute.
Right, but we want to pick the smallest or we want to pick the largest?
Largest.
But I would think that, but then it might be obtuse.
No.
Here's what we'll do. We'll try it out. Worst case scenario, I'm wrong and we just get to do the problem twice. Okay? But I think it's the small side, then you pick the other one, and then you can just use law, and then you can just sum them up and subtract from 180. Let me look at my notes, see if I wrote myself any. I didn't tell myself anything on that one. I'm going to say pick the smallest just because I wrote that down, and then we'll see if I'm right or wrong. Now, remembering that the smallest side is across from the smallest angle, which one of those is the smallest side here? B. Okay. So, or smallest angle rather. Okay, so I want to figure out B. So I want to figure out, so looking at these, I want something that's going to give me B. I mean the cosine of angle B. So I'll write that formula down. So B squared equals A squared plus C squared minus 2AC cosine B. Now we have 2 options on this. We can start plugging in numbers, okay, and then get a number here, and a number here, and a number here, and try to max them up together, and then subtract them from both sides and play that whole game. Or we can try to isolate the cosine B here and algebraically, and then in our second to last step, plug in all the numbers, and then just hit enter on the calculator, and it spits us out an answer. Which would you prefer? You want to try the algebraic way? This is honors pre-cal, so we're going algebra way. I guess we could probably start doing it. So we want to isolate that cosine B right there, all right? So it's kind of, we don't actually even need that. There we go, but that's nice. So I want to get the a squared over there, the c squared to the other side. So let's just go ahead and immediately do that. Let's subtract a squared and subtract c squared from both sides. So b squared minus a squared minus c squared equals negative 2ac cosine b. Then, in order to get this cosine b by itself, we're being multiplied by negative 2ac, so I'm going to divide this whole side by negative 2ac. I'm going to multiply or divide this side by negative 2ac. Cancel. I hate having my unknown on my right hand side, just kind of OCD like that, I guess. So alright, cosine b equals b squared minus a squared minus c squared all over negative 2ac. So let's go ahead and start throwing some numbers here. So 34 squared minus 40 squared minus 66 squared all over negative 2 times 40 times 66. Now when you type this into the calculator, you definitely want to make sure that you're putting parentheses around the numerator, it's this whole thing divided by this whole thing. Otherwise, you're just going to end up divided by, it's going to take all of this and just divide it by the 66 squared divided by that number, okay? So I'm going to walk around and make sure that everyone can key this in properly, okay? So cosine B is going to equal 0 point something, if I remember correctly. I will also type it in. Alright. Maybe. You got it right. 34 squared, 40 squared, 66 squared, minus 2 times 40 times 66. I got something different. I got .9090.
I got .9090.
Yes.
Divide. You have 32 squared, right? So I believe you can divide by. You need to have parentheses around your whole numerator because you're just taking that 66 divided by that. .9090. Yeah. Okay. Okay. Looks good. Here you go, iPad. Yes? Yes, calculator, cheers. Calculator, cheers. All right. You got it? Trey, did you get it? Good. Okay. So cosine B equals .9090 blah 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 blah. Now we want to figure out what actually B equals. So some of y'all saw that. B is going to be, if y'all remember, the inverse cosine. So you do inverse cosine and then you get your calculator, so you just type in answer. Or you hit the up arrow, or if you don't have, do y'all know where the enter key is on these? it's that negative button right there next to the enter. So you can say inverse cosine. Oh, I'll make sure I'm in degree mode, which I am. And then second answer. And you should get 24.61997733. So they want us to round our answer to the nearest tenth. So 24.6 degrees. 4.6 is correct. All right. Check. What is the next smallest answer? The one that's across from 40. So we're looking for A. Looks like we're going to be utilizing this equation since that one has the cosine of angle A. Now, I wonder if we could we're gonna have to do that rearrange thing all over again. Oh, yuck. Isn't there a way that I can just sort of like look at what this is and use that as like one of my alternate forms of the law of cosines? Alright, so that was cosine of B is equal to B squared minus A squared minus C squared over minus 3C. So this one would be cosine, using this as a pattern, cosine of angle A would seem to be whatever angle he is here, it's the same thing here. So possibly A squared, right? Minus, and then this one is A and C, which were those other two guys. So minus B squared minus C squared. Are y'all following along with this? Divided by, and then negative 2AC. So that's negative 2, and then that's the other guys. So in this case, it's going to be minus 2BC. I kind of like that. Makes me want to write this down as another an alternate form of the law of cosines. All right, here we go. Little a was 40. Minus little b, 34. Minus little c, 66. All over negative 2 times 34 times 66. Thank you. 40 squared minus 34 squared minus 66 squared. So I want to walk around again just to make sure that everybody can do that. 40 squared minus 34 squared minus 66 squared divided by negative 2 times 34 times 66. Remembering to put numerator in parentheses and denominator in parentheses if you want to be fancy and do it all in one take. I got 0.8716. Oh, you did the code. Let me look above that. 8716. I see it. Good job. Let me get it. You're doing. Keep going. You did the inverse cosine already? Okay. Yeah. 29.3. A716. Yep. Right? That's the Grace, that looks correct. Check yours. So at this point, since these are all positive numbers, don't feel like you have to do this for an extra parentheses. You look at that as a reference. She got it. We're looking to see what the problem is.
Oh, this is 30.
Yes. Yes. Trey, looking over your shoulder here. Yes, good job. And Emma, I didn't check yours. Yes, okay, great. So we saw saw, that was 0.8716. So therefore, angle A is going to be inverse cosine of that answer. Robert, what'd you get for that?
29.3.
29.3. Okay. So B was 24.6, A 29.3. I wonder what happens if you add those two up and subtract from 180. What do you get?
126.
Say again?
126.
I can't hear you.
126.1.
126.1. Let's check and see what Alex says about that answer. Alex says that's the wrong answer. They do, I'm sorry. You're close. But the problem is that you used two rounded answers to this rounded answer and this rounded answer to come up with this rounded answer. Okay? Don't worry, there's a way we can still get the right answer here. Okay? And the fact is I didn't read the instructions. They say carry your intermediate computations to at least 4 decimal places. Now in these we did awesome. We did like 8 decimal places because we used to do second answer right there. However, we did not have 4 decimal places when it came to figuring out what this thing was, okay? So, let's be a little bit more technical and write on our paper, we don't need to write it for our final answer, but this wasn't 29.3, this was 3481, okay? And this one wasn't 24.6 degrees, it was 24. Those of you, can y'all hit the up arrow to see, get a little more detailed on that?
These won't let you do that.
I know, some 1 or 2 of them had that. Preston, you still got it?
No. I'm sorry, I believe that.
All right. Well, we gotta get the right answer here.
I don't know, I think it's 77 or 99. Should have been 77.
Someone real quick, just y'all can key it over.
You're looking for the one before. 24.6.
You got it? 630.
Wait, which angle?
6325.
This is the one from earlier. That one was A.
Okay.
I think we
What did you have?
That was B.
Wait, that's this one. So
Do you have B?
6 2.
Do you delete?
Yeah, so it's 6. No, it's 619. 6 1.
I'm hearing different answers, so I'm gonna need a.
Why don't we use
Okay,
test
here, I'll just do it right now.
Because, sure, but I'm gonna have y'all verify this. I'm not. All right, we've got two ladies giving us 2 separate answers. I need someone else to verify or deny it. I'm gonna need at least 2 more people to give us. Just run those numbers real quick. This shouldn't be hard.
I got 24.6200 if you round it.
6200. Gonna need more people to verify here. Sorry.
Did I do it incorrect?
That's what we're trying to figure out.
Huh?
I got that number.
Oh,
So
party time. This.
Yeah, that's what I remember. That's, yeah.
909090901.
Yeah, I can confirm with Robert.
That answer.
it's that one.
I can confirm with Robert.
Guys, I'm slow.
Please confirm with Robert. She's confirmed with Robert. I am also going to confirm the 6200 number. That's correct. Okay, so now we're going to say 24.6200 plus 29.3481, adding those 2 numbers together, and we're going to take 180 minus their sum, and we get 126. What did y'all get?
It's so much faster if you just do it.
0.03, but in this for your final answer, to the nearest tenth, so 126.0.
Why don't you just find it using the law of cosine?
Does it work?
Yes. And I did it like 8 minutes before you.
Okay. Well, and that was the obtuse angle,
Yeah.
right? Okay. So that solves our question from earlier. If you do the obtuse angle with the inverse cosine, no big deal, right? Okay. There you go. Dealer's choice here, player's choice. You can choose inverse cosine 3 times, or you can choose to do it 2 times, but then carry these other digits out to 4 decimal places and add them together and subtract them from 180.
Anyway.
All right. So remember how I said that today's situation is gonna deal with the side, 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 or a angle, angle, angle. It defines an infinite number of triangles.
Side
Because
angle, side.
real side, angle, side. Angle, angle, angle can be scaled.
Make a time.
Uh-oh, are we gonna run out of time? Then we better work fast here, y'all.
Sometimes I just wish I was Lincoln boy.
All right. Here we go. Angle C, 109 degrees. Little a, 17. Little b is 70. We got this. Okay? How are we going to find little c? Law of cosine. We're going to say c squared is equal to the sum of the squares of the other 2 sides. 70 squared plus 17 squared minus 2 times their product, so 2 times 70 times 17, and the cosine of the included angle, cosine 109. Are you telling me all I gotta do is key that in, and then take the square root of it?
Whoa.
Yep. 70 squared plus 17 squared minus
Bless
2
you.
times 70. Make sure you play along so you get that muscle memory, that tactile interaction. 2 times 70 times 17 times cosine 109. What?
Easy.
That's the big number. That's the square. Now, you take the square root of that answer. Round it to the nearest tenth, you get. I got 77.2. Anybody agree?
Yeah.
All right. Square root. Yeah, you probably got 5,963. 5,963. Take the square because that's c squared. Okay. We want to take the square root of this. Okay. Now, with the wave of my hand, I'm going to tell you how to solve the rest of this problem. Law of sines.
Whoa.
Yep. Yeah. You would say the sine of A over 17 is equal to the sine of 109 divided by, carry your intermediate calculations to 4 digits. So
77.226.
0.2260, yeah, is what you're going to do in this case. Congratulations, you already know the law of sines. When you get this, then you'll be able to figure out what that mystery number is, add that to 109, subtract that sum from 180 to figure out what angle B is.
So how is it easier to read law of sines?
I meant the derivation and the understanding. This, I think this homework is 3 questions. Maybe, something like that.
Easy time.
Well, I mean, the 3 questions take about half an hour.
It always takes longer when I wait for someone to come up with an answer and someone else to verify. All right, look around the room. You are the smartest in the room. Okay, and in your smartest in math in your grade. Okay, you're all smart here. If you ask a question, you say something. Everyone else is smart. So let's all be smart together. Speak up with me.
We're all in this together.
It's not a closed system. It's an open system. So
Sorry.
The answers are. Yeah.